Hi friends, many major paradigm shifts in recommendation system were borrowed from NLP, and today I will show you how. So, why NLP and not vision model? This is because natural language processing has a natural structure match to the recommendation system. Think about it, a word is like a video or a shopping item, and a sentence is like user's watch history or shopping history. A reader trying to understand the sentences and paragraph. This is similar to a user trying to decide if the shopping or video recommendation makes sense or not by directly engage or not. But if you look at the vision models, it mainly deals with the pixels and images, and there's no direct mapping to the recommendation system element. This is why natural language processing techniques and paradigms fit so smoothly in recommendation systems. Let's talk about the first paradigm, Word-to-Vec, and its applications in recommendation system. The idea of Word-to-Vec is simple. You represent each word as embeddings, so a sentence becomes a list of embeddings. The idea is that words that have similar meanings or correlated, they are more likely to show up in one sentence than not. So think about a sentence as a user's shopping list or shopping cart, and each item in the shopping list can be represented as an embedding. And items that are correlated or similar are more likely to show up in one shopping cart than not. So concretely, here, it is more likely for someone to shop kitchen stuff together in one cart as opposed to shop one of the kitchen items and electronic items together. And this is the idea of item to vec. So this has already been widely adopted in recommendation system. And the idea of item to vec was first formalized in Microsoft item to vec paper. And also Airbnb's 2018 paper showed that they use the same approach for listing embeddings and search ranking. Also, if you look at any models in modern ranking systems, for example, two-hour models and heavy rankers, they all represent items as embeddings. And this idea was borrowed from Word-to-Vec. The second paradigm we're going to talk about is the sequence modeling in recommendation system. There are two main things here. First is the training objective. So in NLP, it is a very common training task to predict the next token, essentially giving the words that already appeared in the sentence. Predict the next word. This is also complete, right? And this actually fits smoothly in the recommendation context. So you can imagine, so given what user has already bought, predict the next item that user might buy. And the second thing is about attention mechanism. NLP uses attention to learn the importance of different words in the sequence. For example, here, the is less important compared to cat or set. Similarly, imagine a scenario like this. A user first browsed all those sports items, and then the user was looking for some electronic items, and then the user come back and look at running shoes. With attention mechanism, we can distinguish the importance of items in the sequence. So in this case, the sports items are more related compared to the electronic items in user's browsing history. So in summary, what recommendation system is borrowing from NLP? In sequence modeling, first is a training objective for next token prediction, and second is using attention mechanism to tell the importance of items in sequence. So the third paradigm is actually very trendy these days in recommendation system. It's about semantic ID. The idea is borrowed from NLP tokenization. In natural language processing, say I have two words. One is worked, one is work. If I naively encode them different IDs, then these two IDs actually doesn't measure the similarity that you and I can both see in work and worked. They are just totally different IDs. So the idea of tokenization is to break this worked into work and ED. So what's powerful about this is that ED is now a more generalized, reusable suffix that can be paired with other words as well. So it'll be helpful for cold start and generalization. Similarly, in recommendation system, instead of representing each video as an ID, we can break down the ID into smaller granular pieces that carries hierarchical and semantic meanings. For example, one video ID can actually be broken down into two-digit semantic ID, and we can use the first digit to represent a higher level category, more broad, such as sports and beauty, and for the second digit, we can use it to represent more granular categories. For example, within sports, we can break down into running, equipment, etc. So similarly, this is supposed to help code start and model generation. So that's it. We just talked about three paradigms the recommendation system borrowed from NLP. But what about other domains, such as AI agent? And we'll talk about it next time. Thank you for watching.